All right, now that we have talked about the domain and the vertical asymptote, let's talk about how to find the vertical asymptote on a function. This is actually really simple. Considering the fact that we've already talked about how to find the domain, the vertical asymptote really is going to go along with that very, very nicely. So how do we find a vertical asymptote? So let's go ahead and do an example. And we're going to do 3 problems. A couple of these should probably look familiar. X over x squared minus 9. G of x we'll say is x plus 3. X plus 3 over x squared minus 9. And h of x we'll say is x plus 3 over x squared plus 9. Alright, so let's go ahead and take a look at the first one. The nice thing is, a vertical asymptote is going to be whatever makes the denominator 0. If that sounds familiar to you, it should, because that's pretty much the exact same thing that we have to eliminate from our domain. There's one catch to it, and we'll talk about that catch when we get to g of x. But let's look at the first one. Let's check out what makes the denominator 0. Well, if we look at that, x squared minus 9 needs to be factored, so let's go ahead and factor that. So we'll get f of x equals x over x plus 3, x minus 3. So now, look at that and ask yourself, what is it that makes the denominator 0? I am not going to write down each one and separate them in this case. I think they should be getting pretty intuitive. But if I were to plug in a negative 3 or a positive 3 into the x's in the denominator, I'm going to get a 0 out of one of those things, so it's going to make the whole denominator 0. So x equals 3 and negative 3 are going to make my denominator 0. Therefore, my vertical asymptotes are x equals 3 and x equals negative 3. Those are the vertical asymptotes. It's the same things in this case that we have to eliminate from our domain. And they're vertical asymptotes because they're not in the domain. That means we cannot touch them. And what that also means is as x starts to approach those values, x equals 3 and negative 3, the graph is either going to go way up to infinity or it's going to go way down towards negative infinity. One of those two things has to happen as you are approaching a vertical asymptote. Because again, it cannot be touched, it cannot be crossed. So a function that approaches a vertical asymptote has to go up or has to go down as it approaches that vertical asymptote. Okay, let's go ahead and take a look at the second one. This is the one where we have a little bit of a catch. Let's go ahead and factor the denominator. It factors exactly the same as what we just did. So we still have x plus 3 on top, and then we get x plus 3, x minus 3 on the bottom. So the x minus 3 and the x plus 3 in the denominator still tell us that x cannot be 3, x cannot be negative 3 in our domain. That does not change. What does change, however, is that we only actually technically have one vertical asymptote. And the reason for that is, what I have is the same factor, x plus 3, on the top that I do on the bottom. Whenever this happens, you lose that one as a vertical asymptote. What it actually creates on the graph is what's called a hole in the graph. This is not actually something that we're going to cover in this particular section, but that would give you what's called a hole in the graph. So when we see something like that where we have the same factor on the top and the bottom, basically we just lose that one as a potential vertical asymptote. The only asymptote that we have left here is going to be this one. Oops, meant to go with a different color there. This one right here. That's going to be the only one that will give us a vertical asymptote. So what would I plug in there to x to make that 0? I'd have to plug in a 3. So my vertical asymptote on this one is just going to be x equals 3. And notice that when I write these vertical asymptotes, I am writing x equals. I'm not just writing the number down. It's x equals because it is a line. It's an equation, so it must be written as x equals. It's very much like when we did an axis of symmetry. That was also a vertical line, and we had to write it as x equals that number. All right, let's take a look at the last one. And the last one, again, we have to look at the denominator here and say what makes that denominator 0. Well, if you remember from one of the previous problems that we did, x squared plus 9, the denominator cannot be 0. In this case, because that is the case, there are no vertical asymptotes here. Wow, that's just horrible. Let's try that again. There are no vertical asymptotes on this one because nothing makes our denominator 0, regardless of what happens in the numerator.